The last skills in the year we focused on are geometry skills. These skills are really important in 6th and 7th grade math. It's kind of a review of vocabulary that they're going to need in order to access a lot of the tools they'll be using in middle school. I try to reach this skill before the end of April so that I make sure we have time to review all of the skills we've learned to prepare them and give them that last shot at solidifying their understandings before the end of the year. But the first skill, Geometry 1, is a basic review of some of the terminology that we might have missed. And it's just a lot of vocabulary. G1. So the first skill they might need is to draw a ray. And so they should be able to say, they know that this is a ray. They know that this is an end point. They should also know what this is. They should know that that's not a line, it's a line segment. And the way I try and remind them of that is if you've ever seen an earthworm's body at the end has many segments. And if I were to measure these segments, I would say he has 1, 2, 3, 4, 5 segments. Well, that's from one point to the other point where the next segment starts. And it's the same with lines. It's a way of measuring a distance from one end point to the next end point. So if you see a line with 2 endpoints, you know it's called a line segment. Okay? Then if you saw these 2 lines, how would you describe them? And there's 2 ways you could describe them. The least specific way to describe them would say they are intersecting, and that just means generally where 2 lines meet. But a more specific way to describe them would be perpendicular. Perpendicular. And that means at exactly opposite angles from each other. So those lines are perpendicular. Most students already know parallel. Parallel lines are of equal distance from each other at all points. So no matter which point I measured, they would be an equal distance from each other at all points. So they will never, even if you kept them going for millions of years, would ever meet because they're always exactly the same distance from each other. That's parallel. And if you were to be asked to create a way to teach a younger student the difference between an acute and an obtuse angle, being able to talk about these definitions and being able to use them is what this skill is all about. So the next skill is Geometry 2. And this gets a little more specific. If I were to have a shape, a triangle shape, and the shape had this in the corner, then could I talk about it? Well, this one's easy. I would say this shape has a right angle. So I would consider that a right angle triangle. I might also say this shape has it's a right angle triangle. I would say it is not, or I would say this line angle is obtuse or acute, meaning less than 90 degrees. And this angle is acute. And this angle is right. if I were to measure this shape, I would say this is a, well, first I would have to measure and see, is this line the same as this line? If it is, then this shape is called an isosceles. Isosceles. And the way I help children remember this is, I think isoskinny, isoski, because isosceles triangles will have two sides the same length and one side that's different, which always ends up smushing the triangle in one direction or another. So you're either going to have a triangle that's very, very flat, or you're going to have a triangle that's very, very pointy. And those are typical of isosceles. Isoskinny, it's a skinny triangle. So an isosceles has two sides the same length, one side that's different, and it is obtuse with two acute angles and one obtuse angle. And being able to use that language is what Geometry 2 is all about. It's talking about the properties of these shapes and being able to identify them based on their angles. Another typical problem you might see is draw a figure that has two parallel sides and exactly two right angles. So then you wouldn't be talking about triangles, you'd be talking about quadrilaterals, which is the general term we use for shapes that have four sides and are closed. So if they have two sides that are parallel to each other and another and has exactly two right angles, then this shape can be talked about as a rectangle. I could also say this is a quadrilateral. I could also say this is yeah, I think those are the basics. So the families of shapes that the children have and the names of them are important. You've got the basic for triangles and for quadrilaterals. You've got the basic shapes. But then you've also got the names associated with each shape. This one would be considered an equilateral triangle because all sides are the same length. And then you should also be able to talk about this one regarding its angles. Acute, acute, acute. And then this one, as we talked about, is an isosceles, an isosceles. Two sides the same length, one side that's different. This one is considered a scalene. It has no sides the same length. And it has one obtuse angle and two acute. When you get to quadrilaterals, you've got just the general term, which usually includes a parallelogram, but a rectangle can also be described as a parallelogram because it has two sides that are the same length. But this one has four right angles. The parallelogram does not. So it's a little more special. You could get more special, like a square, four sides that are parallel, 4 right angles, and 4 sides all the same lengths. Or you can get less special. You could go trapezoid, 1 set of parallel sides, 2 sides the same length, but no right angles. Trapezoid I remember by saying it's like a trap. If a mouse goes in and steps on this wall, the wall goes back up and the rat is trapped. So these are the basic quadrilaterals, and as you can hear when I'm talking about the language, it's really important for them to get comfortable with the vocabulary and use the vocabulary and talk about it when they're talking about these shapes and measure them. So the last skill we go through in 4th grade is Geometry 3, and that's symmetry. Most students have heard about symmetry and can use symmetry. The biggest struggle students have is how do you draw a line of symmetry when not given a line of symmetry? And then the other question is, how many lines of symmetry can an object have? So the first thing I usually do is start students off with a game. I start at one side of the board. My partner or fellow student starts at the other side. And I say, whatever I do on the line of symmetry, match me. So I usually start by scaffolding heavily and say, I'm going to start from my line of symmetry and I'm going to move down and away. Now you move down and away. Now I'm going to move towards my line of symmetry in a curve. Towards my line of symmetry in a curve. Now you move towards your line of symmetry and a curve. Now I'm going to move at an angle straight towards my line of symmetry and down. You move towards your line of symmetry and down. And that stops what a lot of kids want to do, which is this. I do this, and they do this. Or I do this, and they do this. So what they need to understand about the line of symmetry is it literally is mirroring what I'm doing on the other side of the line, and that means talking about it. So once we played this game a few times, then I draw, usually we start with the alphabet, and I say, does this letter have any lines of symmetry? Meaning, can I draw a line of symmetry in this shape in any way that would match? And they usually can see that yes, right down the middle. That's the only one. A B gets a little trickier depending on how I draw it. If I draw it like this, then it would only have one line of, it would have no lines of symmetry because one circle is much smaller than the other. But if the B had exactly the same size circles, then the B would have symmetry, but really only one. C would only have one. Where you get tricky is when you start to get to H, because H has 2 lines of symmetry. And it helps if you draw them in different colors so they can see the 2 lines easier. So if we start with the alphabet letters, we can see how it's a way of talking about and describing shapes and where they are with angles. Often parents will wonder, why is this important? Well, it's important because mathematically, this is how artists judge compositions. This is how engineers evaluate the balance of objects. And this is how computer programmers help a computer to understand where to put objects. So just applying numbers to these lines of symmetry helps to identify the points where we're meeting things. The last thing I need to show is rotational symmetry, which is if you have an object like this, this object has rotational symmetry, meaning no matter how I rotate it, even if I turn it, it's going to look exactly the same. Circles have the ultimate rotational symmetry. They're exactly the same no matter how you rotate them. That's rotational symmetry. The other place we use symmetry is in hospitals. Doctors use symmetry to evaluate different organisms. Animals with backbones have symmetry along their backbone, and that's how they find internal organs. And so we do talk quite a bit about how your backbone is your line of symmetry and how each side of you is a mirror image of each other. But if you look at an octopus has a little bit of symmetry on each side, but it really is more, or a better example is a jellyfish. A jellyfish has perfect rotational symmetry. And then we talk about why animals in the ocean often have rotational symmetry, whereas animals on land have vertical symmetry. And why is that? And how might that particular property help the organism? So math is everywhere, and part of Common Core is getting students to understand real-world applications of these really advanced concepts in a way that introduces it to them step by step by step. Math is really challenging in 4th grade, but it also is super foundational. So if they feel confident and get a chance to be exposed to these concepts now, then when they get into middle school and high school, it's less scary. So thank you for watching my videos, and I hope you've enjoyed them.